Well, hello and welcome back to day 4 of the 3018 CNC machine build. What am I saying? Welcome back to day 4. It just sounds a bit like Time Team. Doesn't remember that Time Team? God, I used to hate that program. They used to come up and dig up some poor bugger's garden and then, they'd say, we're going to find something, buried treasure, and then they'd find a bit of old dirt or a bit of wall or a brick. And some bugger had his garden dug up. God, I hate that program. Right, what we're doing today? Yes, well, I think we're on the last leg. Well, we really haven't got very much left in our box of bits. We've got a few things in a tray down there. Let's go and get some of the remaining items out. Well, I don't seem to be having a lot of luck with the audio on these films because I'm afraid I've just lost some of the audio footage again, because this time it wasn't the batteries that went flat in the microphone, it was actually the batteries that went flat in the receiver. So what I'm doing here is I'm just installing the main control board, and that control board, you've got to install it with some plastic insulators between the framework and the PCB, so that obviously you don't short the back of the connections out when you screw the board down. So that's what I'm doing there. I hope you can see there's some little white plastic spacers, and the screws go through the circuit board, then they go through the plastic spacer, and then finally the ends of the threads on the screws just engage on the T-nuts which are installed in the slotted rail. So I've got the first one fastened in there, and now I'm just fitting the second one. And of course, the more screws that you get in, the more fiddly it actually becomes to fit the final ones, because you can't waggle anything about. So there goes number 3. And I'm just having to slide the nut in from behind there, just push it along with the other Allen key. And then tighten it up. And again, I'm just having to do the same. I'm just using this little metal rod just to push the T-nut in along the rail so that it lines up with the head of the screw thread. And that's the last one tightened up. And now I'll hand you back to that other idiot. Well, I'm not sure if any of you saw me just prodding away with this piece of metal before, just to align these things up, and could have one of our little pop quizzes. Now, does anybody know what that is? I know one person who's going to know. Sam's going to know the answer to this. I just think he'll know. But come on, don't tell anybody, Sam. What is this? Can you see it? Let me bring you in a bit closer. Come on, say now. Last chance. Okay, well, what this actually is, it's an electrode for TIG welding, and it's actually a foliated electrode, a foliated tungsten electrode. So what this is used for, use it for striking an arc when you're TIG welding. Interesting thing about these is that they are slightly radioactive, so it's probably not the best thing to have on the bench. And in fact, I think in some countries, and I think I might be right to say that they are actually even banned in some places. I think I was watching a program that said you can't use these foliated tungstens in places like America and Canada, where they have some very strict nuclear-free laws or policies. Anyway, that's what that is. It's been rattling around on my bench for years, so let's hope it hasn't totally irradiated me. Well, the first connector I'm going to put on is for the spindle motor, and I've got to admit I'm not totally sure regarding this X, Y and Z. I'm not exactly sure which is X, Y and Z. I might have to just double check because I don't want to get it wrong. I suppose we'll figure it out one way or the other. All the stepper motors are the same, so if we get it wrong we can just move them round. But the first one I'm going to plug in, I've just plugged in the spindle motor connection. And the spindle motor connection it's got a Molex on one end, and it's just got a crimped on kind of I don't know what you call it, a female spade connector on the other. And that just goes onto the motor. So let's pop that on. There is a little bit of black ink on there, so sorry, red ink on that side. It doesn't say positive or negative, but it's got a red blob on that side of the motor, which again is a nice little touch. So I'm assuming that's indicating that's where the positive wire goes. So we'll stick negative on there. And positive on that one. And we've got 3 more cables. Are all those identical? Yeah, they're all the same length. So I'm assuming that these can they go either way around? No, they can't. So we'll just put the spindle, don't know what you call that. Like I say, is that Z? I think that might be Z. I'm really not sure. Got that one. Help if I had the right connector, wouldn't it? Yep, that went in nicely. Okay, I've just been and found some spiral wrap because I think it might be nice just to tidy up some of this cable in a little bit. I'm a little bit surprised that they haven't bothered to put a capacitor across the motor, because they're quite noisy. These brushed electrical motors, DC motors, are going to be horrendously noisy, and I thought they might have just done that. I suppose maybe it's not that necessary. Okay, so we've got some spiral wrap. Cut some of that. Spiral wrap doesn't come with a kit, but I think it might just help to keep some of these wires at bay. And I've got some, I've had it kicking around for years, so we might as well use it, mightn't we? Hardest bit of spiral wrap is just getting it started, isn't it? Once you're going, you're all right. This is one of those little jobs that's just quite therapeutic. So we've loomed up that cable, and I think just because it is a bit of a rat's nest, I think we'll just do the same to these others. I quite like doing it. It's quite a nice little therapeutic job to loom these cables up. So I'm guessing this one only needs to be pretty short, doesn't it? Okay, well I've just spent 10 minutes. I have put some spiral wrap around some of the wires just to keep it a bit tidier. And I also found some information online. So just for my own benefit, I've gone away and I've just labelled the axis. So we have got Z, X and Y. So it's as I expected, but I didn't want to take anything for granted because I've not done this before. So about the only thing we've got left in the box now is these little pieces of aluminium, and there's 3 of them. Now I'm guessing these are heat sinks for something, although I've got to admit I'm not exactly sure what they go on. I'm guessing they probably stick on these devices here. I assume that these are the stepper motor drivers, because just looking at the board, well, let me see if we can have a look. Well, that one is some kind of FET, IFR something over, IFR, I don't know if that's 540, I don't know if it's a FET. I don't know if that's 540. I don't know if it's a FET. It's a switching transistor, so looking at that, that looks as though that probably goes and turns on and off the spindle motor, perhaps. What else have we got on here? Can I read that? Oh, there's some ICs on there, but the writing's tiny. Let me have a look. Okay, well, there is an IC on there that looks as though it's coupled to the USB port, so I'm assuming that's some form of, I'm going to say an FTDI chip, but I expect it's basically a it's a USB. I don't know that, I'm guessing. And then interestingly enough, it's got our old friend, the Atmel Mega 32.8p, which we were playing with last week with the open logs. So we've got one of them on this board as well, so I'm wondering if it's running some form of Arduino sketch. And then we've got some other boards up here, and all I can say is I'm assuming that these are the stepper motor control boards, but I don't really know anything more about them than that. I might just have a look at the again, see if there's any information online. So it says it's at the board, it says it's a WoodPecker CNC and GRBL 0.09. So I might go and see if I can find some pictures online of this circuit board built up, just to give me a clue of maybe where these heat sinks go. The fact that there's 3 of them makes me think it goes on each of these stepper motor driver boards, because you're not going to put one on the you're not going to put one on an FTDI chip. You're not going to put one on the microchip pick. We've got a switch, what looks like a switching regulator down here, so that could possibly have a heat sink, but why have they given me 3 of them? So I'm guessing that these must be the stepper motor driver boards and they go onto those 3 boards there. But let me see if I can find out. Well, I've just had a quick look online, and I did find out quite a lot of information. In fact, too much to bore you with, but it looks as though this this board has got these words gerbil 0.09 on it, and it appears that that was some kind of open source project for controlling simple CNC machines. So I don't know if this is just a copy of that work, or it's in some way an official gerbil board. I don't exactly know, but that's what it is.
Keep filming, I'll do it.
Now, interestingly enough, a few people have said that they had problems getting these machines to operate, so we will see, because it says that a lot of the software that comes installed on this board is outdated, but they also point out when you try to upload it, because I think again it uses the Arduino sketches, but they say you can't upload it using the Arduino because it's got no bootloader installed. So you know what, I'm really hoping that we don't have to end up going down the rabbit hole like we did last week trying to install bootloaders and things like that. So fingers crossed it just works.
Run, rabbit, run, run, run.
So I'm going to try and install these heat sinks. So I'm just going to wipe the surface of these. Again, I'm not exactly sure what these ICs are. I'm assuming there's some form of stepper motor driver. I'm just going to wipe off any grease or crud off them because the heat sinks look as though they are these little self-adhesive things. And then we'll try and glue them on without shorting everything out, because it looks as though it would be very easy to short stuff out with these. Well, literally fingers crossed. These pieces of aluminium are actually much bigger than the ICs and the other things that are on there, so I really am hoping that that we're not going to end up, yeah, as I said, just shorting something out. These heat sinks definitely look a bit bodgy. Like I say, it would be so easy for one of these to come into contact with the pads on the side of here, and I think it'll be 24 volts, that board, so I'm guessing if you do short something out, it's not going to be good news. Not sure about that. Guess we'll suck it and see. I wouldn't be surprised if these things will end up falling off anyway. Okay, it's time to plug in our dodgy def adapter, and actually it's not that one, it must be this one. That one. Plug that in. No light on there. Let's check the voltage coming out of that thing, make sure it's not 900 volt. 24.33 volts. Okay, so that's a good sign, isn't it? So we will let's plug the power supply in and see if anything happens. Right, I've got a little red light. Now it came with this very nice swanky USB cable. It's even got an EMC ferret in. Ferret? Why do I keep saying that? EMC ferrets. I'm never going to live that down, am I? Look at that lovely EMC ferret on there. Smells interesting as well. So we will plug that in. Which way does that go? That's gone in. Now I think before we do anything else, I've got to install some device drivers on the laptop, because I did find a little bit more information that just, well, it told you to do that anyway. So rather than ignoring the instructions, let's try and install those device drivers. Now I'm assuming they're going to be on this CD that came with it, but I don't know that. We'll have to try it again. So it looks like the first thing we've got to do is install a USB device driver, because I'm assuming they've used some dodgy version of the FTDI chip. And well, it's given us the name of the driver here, and I'm kind of hoping it comes on this CD, which I've just stuck in my hard drive. Alright, so it has got some firmware here, which it's talking about AVR Dude, which again, I'm not exactly sure. I think AVR Dude was some way of writing to Atmel devices, wasn't it? So they've given us the AVR Dude application there. So maybe there's some automated way here of updating the firmware on here. And there is a file that says firmware. Oh, and they also give you a hex file. So if you've got a hex file, maybe we could just use AVR Studio rather than using AVR Dude, because I'm not really sure, I don't really understand AVR Dude or what any of that's about. But what I'm actually looking for is, I'm looking for the device drivers. Right, that's the one there, CH340SER. So it says it's an application. Let's see how many viruses it's going to install on my machine. Do you want to allow this to change your device? Yeah. I guess I do install. The driver is successfully pre-installed in advance. Okay, so that's a good start. So come out of there. So what else do we need? So we've installed the drivers. Now we've got to, I guess, install something called gerbil control. So let's do that, gerbil control. I'm not sure if we run this from the CD or we actually install it. It just says it's an application. Is that just going to run or is it going to install? I can hear my laptop chunking away, but there's not very much happening. Right, the next thing it's telling us to do is to configure the COM port. So I assume what I've got to do is I've got to plug the USB cable in. The computer should go ping, and then we can look in the control panel and see if we can find a COM port, a virtual COM port. Yeah, it went ping, so it's detected the USB to serial converter. So how do you get into control panel? Can't really remember. Windows 10. Control panel. Come on, somebody tell me, how do you get onto control panel? Maybe I'll type control panel. Is it device manager? Let's try device manager. It's going to bring the ports. USB serial port. Right, it's installed on COM7. So remember we're on COM7. Right. So now we've got to go to settings. COM7, wasn't it? COM7. It's giving me some settings here. I don't know if we have to type in all these or not. Well, it doesn't mention any of these other settings on here, so I'll assume not at the moment. So in theory we should press these buttons now and it should move. Oh. So will it go back? So we've got a right, so I'm assuming this is going to move the bed forwards and backwards now. Let's move that forward again. Ooh. Right, is this one going to make the spindle go up and down? I don't know. Let's try it. Oops. Oh, I didn't want to do that, did I? Okay, lovely. And I guess what I might have to do is read up a little bit on this this gerbil thing now. Now I'm assuming what we want to do is load some G-code. I'm just playing it by ear now. File, open. So where are we going to find some G-code? Is there anything in platform? All right, okay. There's on the picture here, it's got something called iPhone winging it. So I guess we're looking for the G-code file. So let's open that. All right, okay. So that's what we're going to try and print. So I'm just completely guessing now from when I've worked big machines in the past years and years ago, 30 years ago. I think probably what I've got to do is I've got to set a home position for this. So I'm wondering if I can just do that with these. Right, so I'm not exactly sure where to set the home position either. Right, so I'm assuming that we're going to set this part of the bed here as being our home position. I'm just a bit worried because I don't know how big this engraving is going to be, because I don't want to throw the machine off to one side ridiculously. But in theory I think you would normally zero your axis now, so I'm going to zero the X and Y. And, well, actually just for the sake of it we'll zero the Z axis as well. Spindle on off. See if the spindle works. Oh, it does. Right, so in theory we've got everything set up now, so, well, how do we start it? I don't know. Let's just try pressing things at random. So home, Z, 0, reset, Z safe. There must be something to make us run the G code. Open, reset, send. Do we send the G code? Let's try sending the G code. Might have to switch everything off very quickly. I've got an emergency stop kind of behind me anyway, so let's try send. So it looks as though we can see it tracing the word iPhone at the moment. So now it's tracing the N. Oh, very impressive, eh? It did look as though it was plunging quite deep, so I think before we actually do anything for real, I think we need to actually just check that out. Now, I don't know if I'm assuming the plunge depth is it must be something to do with the G code, but yeah, it looked like it was taking quite deep plunges there, probably far deeper than we'd want to cut, because I reckon we'd end up breaking something. And it also looked as though it was cutting quite quickly. So I think probably that's about all I can do for today until I go and read a little bit more about it and find out what I'm doing, because I'm at that point now where a little bit of knowledge is a dangerous thing. So rather than just smashing something, which would be entertaining, I admit, maybe we'll just call it a day there and have another go when I've figured out a little bit more how to work it. But yeah, it's doing something, isn't it?